Okay, next problem. Find all points x, y at which the graph y equal x squared minus 3x has a horizontal tangent. Well, what on earth does that mean? Well, let's picture it first. So here's my handy-duty calculator. It says I should change the batteries. Can we get it someplace where you can see it? Yeah, you can see it right there. That's pretty good. So I'm going to graph what they've said here. Yeah, I pressed the wrong button. And so it was x squared minus 3x. And I'm just going to do that on the standard window. And I think, yeah, that's right. Okay, there's my graph. And so what it's asking us, so just I'm going to copy the picture really quickly. The picture looks something like this, 1, 2, 3. And it looks something, drawing really kind of a horrible, horrible picture. Something like that, but it actually looks like it goes through 3 there, so we'll redo it 3. And so what this problem, so that's y equals x squared minus 3x. What this problem is saying is find that point. And what we mean by find that point is find it exactly. Do not look at a graph and guess at it, no matter how good the graph is. Whenever you're using graphs, you're just having sophisticated guesses. We want to find it perfectly. So, we want to find that point. So we need something to help us. Now, given that we've been talking about derivatives, it's going to have to use derivatives, certainly. Derivatives. So using derivatives, so we think about derivatives and graphs. And when we think about derivatives and graphs, we recall that f prime of x will give, and we'll call it a formula for the slope at a point. That was one of the fundamental applications of the derivative, that it gave a slope at a point. Now I'm thinking that, well, first of all, I'm thinking derivative because this is a calculus class and Mrs. Browse has been talking about the derivative, so it must have something to do with the derivative. But now I've got a graph and I must have something to do with derivatives. Well, graphs, derivatives, that leads me to think about the slope. And so when I think about this point right here, right there, the slope, we've got a horizontal tangent line there. Horizontal tangent. And horizontal lines have a slope of 0. Have a slope of 0. So there's our connection. To find where the tangent is horizontal, find where the slope is 0. Well, right there, slope is 0. Find where derivative, let's put the word the in there, where the derivative is 0. Should have written a little bit smaller, but we got it on there. Or solve f prime of x equals 0. That's what we're going to do to find that point. We're going to solve the equation f prime of x equals 0. Now, in general, now there I tried to explain what we're going to do or why we're going to do what we're going to do, but you might just want to remember this. In general, to find where a graph or function has a horizontal tangent, or tangents as the case may be. 1, find f prime of x, or whatever it is. H, f prime of h prime, q prime, whatever it is. 2, set f prime of x equal to 0. And 3, solve. That's always the basic steps to finding where a graph or a function has horizontal, and I didn't write the word tangent here. Horizontal tangents. Tangent or tangents. So let's do it for this problem. So for f of x equals, and it was x squared minus 3x. F prime of x, it's going to be the limit as h goes to 0 of f of x plus h minus f of x all over h. And we just start doing that one more time. And so that's the limit as h goes to 0 of x plus h quantity squared minus 3 times x plus h minus the quantity x squared minus 3x all over h. All of that is f of x plus h. All of that is f of x. Remember, f of x plus h means nothing but replace all the x's in the formula with x plus h. And then f of x is just the formula itself. Notice the careful use of parentheses. It has to be negative 3 times the quantity, x plus h. I need those parentheses around that x plus h. And then minus f of x minus parentheses, x squared minus 3x parentheses. You've got to use careful parentheses. Again, if we did substitution of h equals 0, we get 0 over 0, which tells us nothing. So we're just now going to start doing algebra to try to cancel that h. So let's just simplify this guy. And so there's the limit as h goes to 0 of x squared plus 2xh plus h squared minus 3x minus 3h minus x squared plus 3x. Just FOILing and distributing. Then all sorts of stuff cancels. X squared minus x squared. Negative 3x plus 3x. And so I have the limit as h goes to 0 of 2xh plus h squared minus 3h all over h. And you have a choice here now. Every term has an h, so you can cancel an h from all terms. Or it's a little prettier to do this. Factor out an h from the numerator. And there's my algebraic goal of canceling those h's. And I get 2x plus h minus 3. And if you get to the point and you can't cancel the h, that you did some sort of algebra wrong, probably it's missing parentheses. Check that. But if you can't find your mistake, you can't legally cancel that h, and you can't find your mistake, you are better off to stop and write me a note saying, there must be something wrong, I can't cancel the h. Being wrong and telling me you know that you're wrong will get you more partial credit than just being wrong. That if you can't legally cancel the h's, there's no next step. So if you get to a point, the h's don't cancel, find your mistake. If you can't find your mistake, write me a note saying, there must be a mistake, can't cancel my h's. Because canceling when you can't just drives me nuts, and you will lose way more points for mistakenly canceling h's than just stopping and saying, I'm wrong. But now we will substitute h equals 0 to get 2x plus 0 minus 3, or 2x minus 3. And so what we have is this, for f of x equals x squared minus 3x, f prime of x equals 2x minus 3. And for those of you that already know the basic rules of differentiation, you know that by using the definition of the derivative, I just spent probably 10 minutes doing something that once we know the rules will take maybe 5 seconds. But there's my derivative. Now, that's not what the problem asked for. The problem said, find the points x, y, y, at which the graph of y equals x squared minus 3x has a horizontal tangent. The derivative isn't the answer here. It's just going to lead us to the answer. And we will officially finish this problem on the next video.